the next one is number 24 on module 7 homework. All right, for which confidence interval for the difference in the mean mu1 minus mu2 would you reject the null hypothesis? Now, whenever you are doing a hypothesis test to compare mu1 and mu2, I should write this down because hold on one second, let me open up a new Word doc. All right. So whenever we test claims about population means or claims about comparing population means, we assume that two population means are equal. Okay, that's the null hypothesis. Okay, so if I write the null hypothesis using those notations, H naught assumes that mu1, let me type these Greek symbols for you. Mu1, where are you? Mu's of 1. The population mean from the first population is equal to mu2. Okay? No? Hold on, I need to make this mu2. Perfect. Now, I'm going to go ahead and change this up a little bit, okay? Imagine subtracting mu2 from both sides, okay? I'll write that line underneath here. Imagine subtracting mu2 from both sides. You can subtract the same quantity from both sides and the equation is still balanced, right? Now take a look. Mu2 minus mu2 is what number? 0, okay? So these two are written in two different forms. Like first one is saying mu1 equals mu2, but then the other one, this one right there, is saying mu1 minus mu2 equals 0. Because if they are truly the same, if you subtract them, you get 0, right? If you subtract something from itself or the same number, then you get 0. So why am I talking about this? Okay? So if there is no difference. If there is no difference, the confidence interval will contain 0 in it. Okay? Seeing a 0 in the confidence interval means that it is possible that there's really no difference between mu1 and mu2. So how can you have a 0 in a contained in a confidence interval? The lower bound has to be a negative number, okay? The upper bound has to be a positive number, okay? If you get a confidence interval that looks like that, the left end or the lower bound stretches down to a negative and the upper bound is a positive number, then you have 0 in between a negative and a positive number, right? So if you get a confidence interval like that, this supports that there is no statistically significant difference, okay? But what happens if you do big number minus a small number, okay? Okay, for example, if you do 10 minus 7, you get 3, right? You get a positive number. If the first number is bigger than the small number, if you do the subtraction, you will get a positive difference. So take a look at this for me. If you construct a confidence interval and the entire confidence interval is positive, okay? The lower bound is positive and the upper bound is positive. Where's the dollar sign? Okay, number sign. What that tells us is that population 1's average or mean is greater than population 2's mean. That's how you get a positive difference from subtraction. You do a big number minus a small number. So if the entire confidence interval is completely positive, that tells us that mu1 is greater than mu2. Let's think about the third case, okay? I'm going to try to make these into bullets. See, in the synchronous class, I get to really talk about these with my students. But for, Nuva Online students, These are the big ideas that you read about in section, I believe, 8.1 and 2. Now, what if you do small number minus a big number? Okay, for example, what if you do 7 minus 10? Well, if you do 7 minus 10, you'll get a negative 3, right? So that's just an example. But you understand if you do small number, take away a big number, you get a negative number. So if you get a confidence interval that is completely under 0, the lower bound is a negative number and the upper bound is a negative number, what that tells us is that population 1's mean is smaller than population 2's mean, okay? So depending on the signs of your confidence interval, you can determine if they are the same or if one is bigger than the other. So knowing this fact, let's read this question one more time. For which confidence interval for the difference in mean mu1 minus mu2 would you reject the null hypothesis? Null is assuming that they are equal, okay? Null is assuming that they are equal. So if the confidence interval is completely positive or completely negative, we are going to reject the null, okay? If it contains 0, that means there's really no difference. So then we don't really get to reject the null, and the null is assuming that they are the same. So which one of these interval is completely positive or completely negative? Let's take a look. Look at A for me. A is stretched down from negative to positive. This contains 0 and in between these two bounds. So not that one. What about this one? Oh, another similar one. It has negative lower bound and positive upper bound, which means 0 is in between them. So that's out. But look at this one. This is saying completely negative lower bound and another negative upper bound. So is 0 in between these two bounds? No, it's not. This is telling us, where's my note? This is telling us that population 1's mean is less than population 2's mean, okay? Which means that they are not equal. So if we see a confidence interval like that, we're going to reject the null hypothesis that was assuming that they are equal to each other, okay? Look at the last one for me. Last one stretches down from negative to positive. Because if lower bound is negative, upper bound is positive, it contains 0 in between. So this one, we're not going to be able to reject the null, okay? So that's how you can do this question. And this one was, all right, let me see if I can click on check. This one was question number 24 on module 7 homework.